So in this problem, we are given a triple integral, and we're asked to find all of the 5 other orders that we can integrate this in and write the integrals out for all of those. So as is a good idea for all problems like this, we're going to start by graphing what region of integration we're working with. So we're going to start from the outside and work our way in. So the limits for dx are from 0 to 5. Let's go ahead and graph that. Say 0 to x equals 5, right? And so these limitations are planar, right? You've got planes at x equals 5 and at x equals 0, and everything is sandwiched between those two planes. But those planes, we're just going to draw this. X equals 5, x equals 0. All right. Now, on the z-axis, we have from 0 to 25 over to 25 minus x squared. All right, so what does that look like? So we already know that 0 would be the origin right here, or it would be a plane that is facing this way instead. And then the other one is some function that of z, or some function of x for z. Let's look at that function. So up here at any limit, there's a hiding equation here, right? So we have z equals 0. For this over here, we had x equals 0. No, not that there. My bad. For this one over here, we have x equals 0 and x equals 5, right? And of course, for this over here, we have y equals 0 and y equals whatever that is. Okay, so z equals 25 minus x squared. What does that look like? Well, I think it looks like a parabola, right? It looks like a parabola that is at 25 in one direction. And yeah, so if this is positive z, then we're looking at a parabola that goes sort of this way, like this. Great. Except down here, instead of, where does this intersect though? Where does this parabola intersect? So if we set x equals 0 up in this equation up here, then we get z equals 25 minus 0. So at x equals 0, sorry, no, at z equals 0, at z equals 0 is where this intersection is going to be. So at z equals 0, we have 0 equals 25 minus x squared, which ends up being, so z equals 0, then 25 minus x squared equals 0. Then we have 25 equals x squared, so x equals 5. Great. Okay, so this intersects at x equals 5. So let's redraw this parabola to match that. And we'll say this intersection out here is all the way out at, well, if x equals 0, then z equals 25. So this is out here at 25. It's not the most proportional drawing ever, but it'll work. Okay. All right. So we have our z bounds down. We go from the xy plane, which is z equals 0, all the way out to this parabola, right? Except this parabola is for z values, right? It doesn't say, well, it says something about z and x values, but it doesn't say anything about y values. Therefore, the y values are free. So at y equals 0, this parabola is true. At y equals 5, right? I don't know, that's not 5. Yeah, y equals 5 or something up here. This parabola is also the same. It's up here. So we have sort of a parabolic cone here. Probably make that look better. So right now we have sort of this solid right here, but we haven't finished yet. We need to do our last bounds for y. And so y goes from y equals 0, which is the plane down here, right? The xz plane, right? And it goes all the way up to 5 minus x. Okay, well, what does that look like? Well, we can figure out it's linear, right? So it's just it's a plane, and it's a line on the xy plane. So let's graph it at z equals 0, and let's go and say that 5 down here at 5 at x equals 5. What is y? Y is 0. So that's an intersection. At x equals 0, what is y? At x equals 0, y is 5. So we got, again, 5 up here. And it's linear, so we have this line right here. Great. But then, as we move along to any other z-axis, right, because this equation doesn't say anything about z, this line still holds true. So we have this line all the way out here too. Right? So we have another plane out here intersecting everything. Okay, so we have a plane at x equals 0 to, let's go ahead and draw that in there. This is getting pretty confusing, right? So let's simplify it a bit. So what all this ends up coming out to is some shape that looks like, well, we can get rid of this edge right here. Let's see. So we have sort of a bisection that's created by this plane and this parabolic shape right here. Then we have another bisection that's created by this plane and the xy axis. Sorry, the yz plane. Then we have another bisection that's created by the yz plane and this parabola here, because that was another one of the limits that we had. Okay. And of course we have this intersection over here, which we've already drawn. And you can kind of see the solids starting to come together, right? It's all that area right here. Great, so now we have some idea of what our solid looks like. I mean, some idea. It doesn't look very good, but let's clear up this drawing a little bit. All right, beautiful. So now we've clarified our drawing a bit. Let's go ahead and label things. Let's label each surface. So this front surface right here is going to be what is this? Y equals 5 minus x. This bottom surface down here is equal to is y equals 0. And let's see, this surface right here is z equals 0. This surface on the back side here is x equals 0. This surface on the front side here is let's see. So it's going to be 1 over x. No, it's going to be z equals 25 minus x squared. And that is all of our faces. Great. So now that we have all these equations, let's write our, well, these are all of our equations for our bounds, right? So we can rewrite them in different orders so that they work for different orders of integration. So let's write our first order of integration. Okay, so we're going to find our limits for each of these going from or our bounds for each of these going from the outside in. So going from the outside in. The reason that we're doing that is because each inside integration can have limits that are equations of each of the outside variables. So dz, since it doesn't have any variables outside of it, can only be an equation of constants. It can't be an equation of any variables. So z, looking at this, goes from z equals 0 all the way out to z equals 25, right? So it's simply that. That's all that we write. 0 to 25. Okay, now x is a little more complicated. X can have limits which are a function of z. So we look at the xz plane here, right? We look at this face, which is on that plane. And we say, okay, so for that face, if z goes between 0 and 25, right, then what are my bounds as I go across from that axis to x? My first bound is just x equals 0. And my second bound is whatever this arc is, right? This arc is defined by z equals 25 minus x squared. But we need to put it in terms of x. So we're going to solve this equation for x. what you get out of that when you do that is, let's see, so x squared equals z minus 25. So x equals the square root of z minus 25. All right, so we can put that in our upper bounds, z minus 25. Okay. Now for our last set of bounds for y. So now we have this area, right, that we're already working with, right? Now from this area, we go up off that area. We say, okay, for any point on this area, when I go up, what is my lower and upper bounds? So our lower bounds is just y equals 0. It's this flat plane down here. And our upper bounds is whatever this slope is right here, y equals 5 minus x. Now it needs to be in terms of y, but it already is. So we can go ahead and put that 5 minus x up here. Great, so that's one down. We have our answer for that. Let's put it down here. And let's work our next one. All right, so this time we're doing dz, dx, dy. dy is our outermost variable. So it's going to be a constants, right? That's our limits on that are going to be constants. So we're going from 0 to 5 on y. That easy, right? 0 to 5. Now x as a function of y, right? X as a function of y, not x as a function of z, not x as a function of z and y, just x as a function of y, right? What are my limits there? So we have our y values that we've already decided here. We're going out on the x to see where we run into whatever's next. And we hit this function right here. That function is y equals 5 minus x. Except we need to rewrite that function so that it's in terms of x. So how will we do that? That means x equals 5 minus y, right? Okay, so it goes from 0, it goes from x equals 0, right, which is this line right here, to this line right here, which is 5 minus y. 5 minus y. Great. Okay. Now for z, we're going from, we've got this side that we've already done, right? We started with this line here, then we went from this line to this line here. That's made all of everything on this side, right? And then we're going to go out in the z direction from any point on this projection right here. We call this a projection. So any point from this projection out to here. And we eventually run it into this side right here, right? So z has a lower limit. It's a lower limit of 0, right? Because z equals 0 is just this face, right? Because it's this whole plane. And then z equals whatever this is. Whatever this face is, we need an equation for it that's in terms of z. We already have an equation that's in terms of z for it. So z equals 25 minus x squared. Okay, now that's it for that integration, order of integration. Okay, next we're going to do dz dy dx. So x is the outermost variable, so we're going to start with that. goes from 0 to 5. 0 to 5. Then y as a function of x goes from x equals 0, right? Or sorry, y equals 0 down here, goes up and hits this line right here, which is this equation right here, but we need to set it in terms of y, which it already is. So we can do 5 minus x. Great. And then z goes from this projection we have down here all the way out to here. So it's going to be the same as it actually was before. It's going to be from 0 to 25 minus x squared. All right, now we're going to do dx, dy, dz. Since dz is our outer variable, start with that. dz goes from 0 to 25. Great. dy goes from, okay, so now we're starting from this line that we already did, which is our z-axis, and we're going up on our, to see our, as y varies, right, what are our bounds? We end up hitting this line up here. Well, what is this line? This line is y equals 5. So y goes from 0 to 5. Because at any point, right, no matter what z is, right, even though we can have a function that's dependent on y, at any point, it doesn't matter we can have a function that's dependent on z for y, but it doesn't matter which z value we pick, y is always going to be equal to 5. Okay, now we have this whole face, and we're going to go this way and see what we run into, right, on the x-axis. But wait a second. We actually have two different functions that we could end up running into. We could end up running into this one right here, or we could end up running into this one up here. So what happens now? What happens now is that we just write both of them, kind of, and I guess see what happens from there. But not really, because now we need two separate areas of this back face, right? We need two separate areas of this back face. One that runs into this face right here, and one that runs into this face right here. Okay. So let's go ahead and work on that. So that means that we're going to need two different integrals. Let's do let's say that they're gonna look like this, right? Because this area is going to run into this one, and this area is going to run into this one. So let's do this first one. So it goes from 0, right, not to 5. It goes to 0 to whatever this function right here is. Well, what is that function? It's the projection of intersection between this function and this function. So how do we figure that out? Well, we know that this shadow must be parabolic, right? This is a shadow of kind of a tilted parabola here. And we know that that parabola intersects here and down here. We also know that this must be the peak of the parabola, because if you remember, this was the peak of the parabola here before it went down. So this must be kind of the peak of the intersection as well. Okay, just from kind of geometrically reasoning there, we can come up with an equation for it. We can say that z equals, well, it's a negative parabola that has a peak at 25 over here. So 25 minus z, sorry, not z, minus y squared. However, it's not just minus y squared because that would put the peak down here, right? The peak is all the way up here. So it's minus y minus whatever this offset is. This is offset by 5. So we're going to do minus 5 squared. All right, now we just need to rewrite that equation in terms of y. So we do z minus 25. We negate that, then we have y minus 5 squared, then we have y equals the square root of 25 minus z plus 5. Okay, so that's our upper bounds in terms of y. Okay, then we would plug that in as our upper bound, and that would be 25 minus z plus 5. And then from there, we would have our x values. So x goes from this whole area right here over to this right here. So this would be x from 0 to this in terms of x, which we already solved for previously, which comes out to be square root of 25 minus z. Okay. Now that's not it for this integration because we still have to figure out what the value is for the integration of this part up here, right? So that's going to be added on to whatever we have for this, because the integration is basically just the volume. The triple integration is basically just a volume, right? So we already have the integration over this volume here. We need to figure out what the integration is over this volume all up here, right? All this area inside of here, right? Between this face here and this big kind of triangular face up here. Okay, so let's figure out what the next part of that is. We have roll fxy z dx dy dz, and still 0 to 25, but this time this line is our lower bound for because we went along the z-axis, right? And now we're going to go up in this direction, right? We already did this section, right? So next we need to do this section. So we're going to go from the square root of 25 minus z plus 5, because we said that's the equation for this line, right? We're going to go all the way up to 5, because that's the equation for this line, y equals 5. All right, and then we're going to go from 0, going from here along the x-axis, right? Projecting out this way till we hit this face right here. We're going from 0 to x equals y minus 5. Great. So the sum of this and this is the answer to that. All right, we got one left to do, dx, dz, dy. Okay, so let's start with y. Y goes from 0 to 5. Z goes, okay, we're going out this way. Z goes from 0 out to 25, right? Because it's just a line on this side. But then, okay, now we have this rectangle again, and now we're going in the x direction. We run into the same problem as before. So we're going to need to use these two different regions that we came up with again, except this time we're going to rewrite that equation that we came up with in terms of, well, we're going to write it up in terms of z. Good thing to start out with, we already have the equation in terms of z right here. So first we're going to go 0 all the way out to that line, that dashed line that we have there. And that is going to be 25 minus y minus 5 squared. All right, then we have from that little section of that wall all the way out, ends up hitting this section here. And we have the equation for that. And we need to write it in terms of x. So it goes from 0 to, from x equals 0, right? All the way out to x equals 5 minus y. Okay, and again, we just rewrote it in terms of x. Great, now we need to do the other part, because we can't just leave it at this. We need to get both parts of that. All right, okay, so y first, 0 and 5, same as before. Then this time we're going to make this dotted line our lower bound, because we're coming from the y direction. Remember, we did y first, right? So we're going out this way. So this time, we already did that. So this time, we're going to go from this line out to here, right? We're going to get this region right here. So this dotted line is our lower bound. So that means our 25 minus y minus 5 squared, right, for z is our lower bound, and our upper bound is z equals 25. Then for x, right, for this portion right here, we go out from here in the x direction, and we run into this face right here. So that means our lower bound is 0, is x equals 0. And our upper bound is, well, we can solve this for x, and we get, we already figured that out previously. We get square root of 25 minus z, square root of 25 minus z. Awesome. All right, after all that, these are all the different orders of integration that we got besides the one that was already provided for us. And that's all of the orders of integration that are possible. Thank you for watching. If this helped you out any, please leave a like, leave a comment, and check out some of my other videos. Thank you.